Hey everybody, it's Mr. Carr again. Today we're going to be talking about 5.4, analyzing graphs of polynomial functions. Okay, so we're going to look at the graph of f of x equals negative x to the third minus 4x squared plus 5. The goal is to put in a calculator, and then we're going to try to transfer that on the paper. And then after that, we can describe our end behavior and domain and range. This is the bare minimum what we want for graphs. So you look into your graphing calculator, you're going to want to find zeros. You're going to want to find turning points, and you're going to want to find y-intercept. I can do y-intercept without the graph, but we can just see it on there too. Okay. So zeros, remember that's any time where the graph crosses the x-axis. Now, based on your degree, the possible number of real zeros is equal to the degree of the polynomial. And so when we say possible, what that means is the maximum of that. Okay. So let's say we have a polynomial, like if I say a to the n power, or let's say a times x to the n power, and that means I have the nth degree for my polynomial. Okay, so I can have a maximum number of n zeros. Okay, so that's the maximum. So that means if I have a fourth degree, you could have up to 4, but you can also have less than that. So the other part of that too is if you have, let's do this, yeah, already up here. If you have an odd degree, you have to have at least 1 0. Okay. Because you think about the n behaviors of odd degrees, it's going to go up and like it's going to go this way where it goes opposites. So it has to cross the x-axis at some point. Even degree can actually have 0 real zeros. Okay. So that's a possibility. So like we said, we have fourth degree. We can have 4 zeros, 3 zeros, 2 zeros, or no zeros. Okay. No real zeros. If we have third degree, I can have 3 zeros, 2 zeros, or 1 0, but I cannot have 0 zeros. Okay, turning points. This is the points where the maximums and minimums occur. So this would be like this. Here's my turning points here and here. So that's what we refer to turning points, like those spots there and there. Kind of look like a vertex, but if I have like more than one vertex in a way, then I got to account for that. There's more than one turning point. Okay, now the maximum number of turning points is 1 less than the degree. So again, using this as my polynomial idea, a times x to the n, that means n minus 1 turning points are possible. Okay, so that means possible, so we could have less than that actually. So there are ways to make a polynomial where it actually has no turning points, even though it's third, fourth, or fifth degree even. Okay, and the y-intercept will cross the y-axis. So for this example here, I'm going to just draw a rough sketch on the side. But the goal is I want to find all these important pieces, zeros, turning points, and y-intercept from my graphing calculator. Okay, so I'm going to go ahead and complete this. Okay, and then let's go to my graphing calculator. Looks like this. So ignore the ads at the top. Y equals, you start with that. So y equals negative x to the third minus 4x squared plus 5. So we're going to go to our graph like this, and they can see roughly how it looks. Don't forget, you are finding zeros and everything. So that means, all right, pull up my calculator real fast. Okay. So that means you're finding all those different things by doing second calc and doing like 0, number 2. Okay, so left bound. So let's say, for example, you see where the cursor is very roughly there. We're close to the one that's in the middle. So that means I'm going to do left bound. It's going to be below. Hit enter. Right bound is above. And it tells me right there it's negative 1.38197. Okay, so I have an approximate 0 there. So the other thing I want to do is if you hit second calc, you have minimum or maximums. I'm going to do both of them because if I go to minimum, okay, the minimum is the one that's on the valley, the low dip. So if I go left bound of that, so I keep hitting to the left until I can get anywhere to the left of that curve, hit enter, go to the right, make sure again I'm to the right of that curve there, hit enter, and there it tells me right there it's negative 2.66 or negative 2.6 repeated, and y is equal to negative 4.8148. Okay, so that's one of my turning points. I'm going to do the same thing on the other one. So, but this time when I go to the calc menu, because it has the mountain shape, I'm going to go to maximum, number 4. Sorry about that with the ads coming in for this this is app, I guess. All right, so I'm going to go to second calc and go to the maximum, number 4. And now this time I'm going to make sure I'm just anywhere to the left of that curve. So hit enter there. Right bound, I just need to go on the other side. And there it is there. Now, you see something like this where it's 3.52 and then e to the negative 8. That's actually with scientific notation, it's 0.000000008 or 352. That's really close to 0. So this is actually crossing at the 0.05, which means it's also my y-intercept. Okay, so we're going to go back and I'm going to, let's write some of those down real fast. So again, you would find the rest of the zeros on your own, but for this case, you would have zeros at negative 3.6180, negative 1.3820, and the other one was 1, 0. My turning points, my 2 turning points occur at negative 2.6 repeated, and then negative 4.481. And the other one was at 0.5, which is also my y-intercept. So now the goal is I just want to put these points on there and see how my graph looks. So if I cross at 1, 0, negative 1.3, so it's going to cross about right about there, and negative 3.68. So 1, 2, 3, and a little bit past halfway right there. Okay, my minimum, negative 2 and 2/3. 1, 2, 3, 4, and a little bit past goes down about here. And I'm crossing at 0, 1, 2, 3, 4, 5 up here. So now it's just a matter of just following my dots. So it started up here, crosses here, comes back up, and then goes down like this. Okay, doesn't have to be perfect, just a rough sketch. Now I can do my end behavior and domain and range. So as you notice, for end behavior, we always start the same way. X approaches a positive and a negative infinity. So as we go off to the right, my graph is going down forever. So f of x approaches negative infinity. As it goes to the left, it goes up forever. So f of x approaches positive infinity here. For domain and range, okay, if we look to the left and right, are there any limits on what the x values can be? None. If I look low to high, are there any limits in that? No. So they actually both look the same. For interval notation, it's going to be negative infinity to infinity in both the x and y direction for domain and range. Okay, so that is it for kind of like looking for those key points and putting them on the graph here. The other skill we'll talk about is how do we take some descriptions and turn it into a sketch of a graph. Okay, so again, we're going to do a nice rough sketch here. And that's enough there. Okay, so we have a 4th degree polynomial with a positive leading coefficient. So let's talk about that real quick. What happens when we have positive and negative leading coefficients? So you've probably seen some examples like this, but here's the idea. If I have a positive with an even degree, then that means my end behaviors kind of do this. They go both up. If I have a negative leading coefficient and it's in still an even degree, then my end behaviors go down. It just flips the other way. If I have a positive odd degree, I'm going to get this. I'm going to get lower left and upper right for my end behavior. So I might be blocking that. There we go. My positive odd degree will go lower left and upper right. Negative odd degree flips that. So it's going to go up and to the left and down and to the right. So that's how I can know from this one. If I have a 4th degree that's even and it's a positive, so I know very roughly the end behaviors are going to go up and up. I have zeros at negative 2, 0, and 1. So now I'm going to go ahead and plot those. Negative 2, 0, and 1. I also have a maximum at x equals 1/2 and a minimum at x equals negative 1. So I'm going to go ahead and just draw these like lines like this so I can get a rough idea. It does not specify where like what the actual maximum or minimum values are. It just says it's a maximum occurs at this. So I can have a minimum value anywhere I want below the axis, and I can have a maximum anywhere I want above the axis over here. Okay, I know it's a for minimum and maximum because of the way my zeros are. It has to do something like this, where it comes up in there, and then for this one, it has to go down and like back towards that zero. Okay, so and again, because of the behavior, I know it's got to end up here and end up here. So I've got everything I need to just draw a rough sketch. I'm going to choose where I want to put my minimums and maximums at, but I just got to make sure they cross at the x values of -1 and +1/2. So I'll start up here, and we're going to come down and just going to dip down here and then come back up. And I'll just go right here and just go right away. Now here's where I got to make sure I'm careful. Now, a lot of people would like to think that because I have an even degree, I could do something like this, where I just go forward and keep going like that. The problem is I don't have another zero. If I did have another zero, I would have listed it here. So that means I can't dip below the axis here. This does not exist. So instead, the graph is actually going to hit that at that zero and then just bounce up. And that's how I can have my end behaviors there. I chose to put a minimum maximums at those 2 points, but I'm still following on here. I have these 3 zeros. I have a maximum at 1/2, so maximum at 1/2 is right there. And I have a minimum at x equals -1, which is down here. Okay, you can be more descriptive, and these problems might have that in the future, but for now, that's it. I've done everything it needs for this this graph. Okay, and so that's all 5-4. We're just, again, analyzing those graphs of our polynomials, looking for turning points or maximum minimums, kind of mean the same thing in this case. We're looking for even and odd degrees, what happens with that, with their end behaviors, and then looking for those zeros to make sure we understand how the graph looks. All right, that's it for today. Take care.